Schrodinger equation. We are all familiar with the classical mechanics, and if a particle of certain mass m is moving with certain velocity v, then it will have a certain energy, that is E equal to kinetic energy plus potential energy. This is we already know from classical mechanics, right? And we know this energy is equal to, where kinetic energy can be written as p square by 2m plus potential energy is some function of r. So this is the total energy of this particle, right? Now the question is how we can represent this energy of a particle in quantum mechanics. That process is called first quantization. So analogous to energy in classical mechanics, we will make an equation or expression for energy of a particle in quantum mechanics. That is called first quantization. That is, in quantum mechanics, everything is operator. So the energy in classical mechanics become operator in quantum mechanics. That is represented by E cap. So E cap is equal to P cap square by 2m plus V of r. Here what is this operator? Here this E cap operator is defined as I h cross dou by dou t, and P cap operator is defined as minus I h cross del, where del equal to I dou by dou x plus j dou by dou y plus k dou by dou z. So for a special cases like px operator, then it will become minus I h cross dou by dou x. Okay. So this E and P are operators. So this operator should operate on something, right? That is, here this operator will operate on a wave function psi, that is equal to p square by p cap square by 2m plus v of r, operating on a wave function psi. So this psi represents the state of the particle, right? So in the wave function psi, the every information about the particle is hidden. So by using these operators, we can find out these hidden parameters. That is like, suppose you have a bucket of water, you can use a thermometer to find out its temperature, you can use a weighing machine to find out its mass, okay, like that. So the every property of the particle is included or associated with the wave function, and by using these operators, we will measure the each property, right? Now we can substitute for E and P, so we can rewrite this equation as I h cross dou by dou t of psi is equal to minus h cross square by 2m del square plus v of r into psi. Here this entire term called as h. So again I can rewrite this equation, that is I h cross dou psi by dou t is equal to h psi. This is called the time dependent Schrodinger equation. Why? Because in the equation you can see the explicit dependence of time t. That is why it is called time dependent Schrodinger equation. Now I am going to consider a general wave function psi, that is equal to a e raised to I kx minus omega t. Now we can substitute this value in this time dependent Schrodinger equation. What we get I h cross dou psi by dou t, that is a e raised to I kx minus omega t into derivative of this time, that is minus I omega, that is equal to h into psi, that is a e raised to I kx minus omega t. That is what we get. Here there is a I, here also I, so I into I is minus 1 into minus 1, so it will be positive, that we get h cut omega psi is equal to h psi. where h got omega, I think you already know it is nothing but energy. That is, we get E psi is equal to h psi. This is called time independent Schrodinger equation, because in this equation you can see any explicit time dependence, and here this h is actually operator, that is Hamiltonian operator, right? So by operating this Hamiltonian operator on a wave function, we can find out its energy. Current density J. We know time dependent Schrodinger equation, that is IH cross dou psi by dou t is equal to minus h square by 2m del square psi plus v psi. And let us consider this potential V is real. That means conjugate of V will be equal to V itself. Now I am going to take the conjugate value of equation 1, that is minus IH cross dou psi by dou t is equal to minus h square by 2m del square psi star plus V psi star. This is equation 2. Now I am going to multiply the equation 1 by psi star time. So what we get? We get it is equal to IH cross psi star dou psi by dou t is equal to minus h cross square by 2m psi star del square psi plus V into psi star psi. And I am going to multiply the equation 2 by psi on left hand side. So what we get? We get minus IH cross psi dou psi by dou t is equal to minus h square by 2m psi del square psi star plus V into psi star. This is equation 4. I am going to subtract equation 4 from equation 3. So what we get? We get IH cross psi star dou psi by dou t plus psi dou psi star by dou t. Here I miss this star, equal to minus h square by 2m into psi star del square psi minus psi del square psi star, and these two terms will cancel each other. Okay, so this is our final expression after subtracting equation 4 from equation 3. Here I am going to do some mathematical manipulation. Here del square is nothing but del dot del operator. Okay, so I can rewrite this equation as follows, that is IH cross psi star dou psi by dou t plus psi dou psi star by dou t is equal to minus h square by 2m into, I am taking one of the del term outside, dot psi star del psi minus psi del psi star. Here I can rewrite this term as dou by dot t of psi star psi, right? And I am taking these terms to the right hand side of the equation. So what we get? We get minus h by 2im del dot psi star del psi minus psi del psi star. And here, what is this term? Psi star psi? It is nothing but mod psi square, that is equal to distribution function rho, that is dou rho by dou t is equal to minus del dot h cross by 2im into psi star del psi minus psi del psi star. Here this entire term is called probability current density J. That is, we got dou rho by dou t is equal to minus del dot J vector. And this equation is called as equation of continuity. So we got one of the equation for current density, that is J is equal to h hat by 2im psi star del psi minus psi del psi star. This is the first expression. For current density. There is some other expression for current density. That is why I am calling this as expression A. Now we are going to find out another expression for current density. Suppose a wave function psi is given. Then we can find out psi star del psi and psi del psi star. Suppose for psi star del psi we got a complex value, that is a plus ib. Then psi del psi star is nothing but the complex conjugate of this one. That is, we get this is equal to a minus ib. That is, when taking complex conjugate, we have to replace, if there is some items in the expression, we have to replace that item by minus item. And if minus item is present in the equation, then we have to replace this minus item by item. And this process is called taking the complex conjugate of the function mathematically. Okay, so complex conjugate of psi star del psi will be equal to a minus ib. Now we have to find out what will be the value. What will be this value? That is psi star del psi minus psi del psi star will be equal to a minus a, that is 0, plus ib minus ib, that is 2ib. Therefore, we get J is equal to h hat by 2im into this term is equal to h hat by 2im into 2ib, right? So here we can cancel this 2i and 2i. So what we get? We get J is equal to h hat by m into b, where we know b is the imaginary part of psi star del psi. That is, expression for J will be equal to h hat by m into imaginary part of psi star del psi. This is the expression B. So another expression for finding out the current density. One important note. Current density of a real wave function psi is 0. I tell you an example also. Suppose a wave function psi is given, that is a sin k x. Here there is no items, that means this wave function is real. Now we can find out its psi star. So what we get? We get again this a sin kx. So what is the value of psi star del psi? That will be equal to a sin kx into dou by dou x of a sin kx. That is equal to mod a square sin kx into derivative of this term, that is derivative of sin kx is cos kx into k. That is equal to mod a square k sin kx into cos kx. This is psi star del psi. Now we have to find out imaginary part of psi star del psi to find out the current density from expression B. So what is the imaginary part of this term? There is no imaginary term, right? That is, this is equal to 0. The imaginary part means the coefficient of I term, right? So here there is no I term. So imaginary part of psi star del psi is equal to 0. That is why I told you the current density of a real wave function is 0. Note 2. Current density of complex wave function psi. Let us consider a complex wave function psi that is equal to a e raised to ikx. Now we can find out its conjugate value, complex conjugate value, that is psi star is equal to a star e raised to minus ikx. Now we can find out psi star del psi, that is equal to psi star is a star e raised to minus ikx into dou by dou x of a raised to ikx. So what we get? We get psi star del psi is equal to a star e raised to minus ikx into derivative of this time is a into e raised to ikx into derivative of ikx, that is ik. So what we get? We get psi star del psi is equal to a star a into remaining part is ik, that is psi star del psi is equal to a star a is mod a square into ik. Now we can use expression B, that is current density J is equal to h cut by m into imaginary part of psi star del psi. So what we get? We get J is equal to h cut by m into imaginary part of psi star del psi. Here you see I term is there. So the coefficient is imaginary part of this term, that is mod a square into k. That is, I can rewrite this expression as J is equal to h cross k by m mod psi square. I think you are familiar with this h cut k value, that is momentum p. Therefore, I can rewrite J is equal to p by m mod a square, where we know p is equal to mass into velocity. Therefore, p by m is equal to velocity. So this value is velocity and a is the amplitude of the wave function, maximum amplitude of the wave function. So we can write J is equal to velocity into modulus of amplitude square. So this is the expression C. Third expression for finding the current density. Examples. First example, a wave function psi is given, that is equal to a e raised to ikx plus b e raised to minus ikx. Find current density J. So how we can find out? We know J is equal to velocity into modulus of amplitude square. So here what is the velocity of this wave? See, this first term representing a wave traveling in the forward direction because it is plus kx, right? And this term represents a wave traveling in the negative direction because it is minus ikx. Okay, so it is representing the minus x direction, and this one is, first one is representing the positive x direction. So first wave is traveling in the forward direction and second wave is traveling in the negative direction. Okay, and what is the velocity? Velocity is equal to h cut k by m. Here what is the k value for first time? That is k only, that is h cut k by m into amplitude square. What is the amplitude? Amplitude is a, that is modulus a square plus, and the velocity of second time is, see, it is in the negative direction, that is minus h cut k by m. Here this value is k only, right, into amplitude square, that is amplitude is mod b square, that is we got this is equal to h cut k by m into modulus of a square minus modulus of b square. Second example, psi is equal to a e raised to ikx plus a e raised to minus 2ikx. Here we have to find out j value, that is j is equal to again velocity into amplitude. So here the first time is traveling in the forward direction and second wave is traveling in the negative direction. And what is the velocity we can derive from the first time? That is h cut k by m into amplitude square plus, what is the velocity we can derive from the second time? That is 2k, that is 2h cut k by m into mod a square. Here this velocity is in the negative direction, so it is minus. So we get j is equal to minus h cut k by m into mod a square. Third example, wave function psi is given, that is psi is equal to a e raised to ikr by r. Find j. Here what we get? J is equal to h cut k. K is here k only by m into magnitude square. Here the magnitude is a by r time, that is a by r mod square. One more example, fourth one, that is wave function psi is given as 1 by root a into e raised to minus mod x by a plus I p by h cross x. Find the j. Here this entire term is amplitude and we know p by h cross is equal to k, that is we know p is equal to h cross k. Therefore p by h cross is nothing but k. So what we get? We get j is equal to h cross by m into, here the value is k into modulus of amplitude, that is 1 by root a e raised to minus mod x by a all square. The probability current density for the real part of the wave function is, actually we discussed this problem earlier. I told you a naught, that is for real part of the wave function the probability current density will be equal to 0. That is if the wave function is like psi is equal to raised to plus or minus kx, then the probability current density j will be equal to 0. Here in this question, a wave function psi is given, that is a e raised to ikr into r0 by r, where it is specified for r equal to 2r0, they are asked to find out probability current density j. What is probability current density j? We know it is equal to velocity into modulus of amplitude square, right? That is how we can find out the velocity from this term. That is, here it is k only, that is h cut k by m is the velocity into amplitude. What is the amplitude? The amplitude part is a into r by r0 by r, that is a into r0 by r all square modulus square. And here they told one condition, that is R is equal to 2 or 0. So we have to substitute for that value also. So what we get? We get J is equal to h cut k by m modulus a square into 1 by 4. Right. Here in the question it is asked to find out the probability density in units of modulus of a square h cut k by m. So what is the answer? The answer will be equal to 1 by 4, that is 0.25. Applications of Schrodinger equation. Application number 1. A wave function psi is given and they are asked to find out the potential of the particle. Example problem. The wave function of a particle is given, that is psi is equal to sine pi x by a e raised to minus I omega t. The question is to find potential V of the particle. How we can find the potential? By solving the Schrodinger equation, we can find out the potential. So what is the Schrodinger equation? We know time dependent Schrodinger equation is I h cut dou psi by dou t is equal to minus h cut square by 2m del square psi plus v psi, where del square operator is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. Here the given wave function is a function of x only. So when we are solving for dou square by dou x square, we get value equal to 0, and for solving dou square by dou y square also, it will be 0. So the Schrodinger equation will reduces to I h cross dou psi by dou t equal to minus h cut square by 2m dou square by dou x square of psi plus v psi. Here we have to substitute the values for psi and solve this equation, then we can find out the potential V of the particle. So first you have to calculate dou psi by dou t, right? That is dou psi by dou t is equal to derivative of this function with respect to time, that is sin pi x by a into e raised to minus I omega t into minus I omega, where this entire term is nothing but wave function psi. So we get dou psi by dou t is equal to minus I omega psi. Now we have to evaluate for this term, that is dou square psi by dou x square, that is equal to dou by dou x of dou psi by dou x. Okay, so first you have to evaluate dou psi by dou x, that is equal to derivative of sin pi x, that is cos pi x by a into pi by a into e raised to minus I omega t. Now again we have to take its derivative, that is dou square psi by dou x square. We get derivative of cos, that is minus sin pi x by a into pi by a all square e raised to minus I omega t. Here also see, this sin pi x by a into e raised to I omega t is psi itself, that is dou square psi by dou x square is equal to minus pi by a all square into psi. Now we have to substitute all these values in the Schrodinger equation, that is I h cross dou psi by dou t is equal to minus h cut square by 2m dou square psi by dou x square plus v psi. Here we have to find out the potential V. So I am rearranging this equation, that is v psi is equal to I h cross dou psi by dou t plus h cross square by 2m dou square psi by dou x square. Now I can substitute these values, that is v psi is equal to I h cross into minus I omega psi plus h square by 2m into dou square psi by dou x square, that is minus pi by a all square psi. So I can find out the potential V is equal to h cross omega minus h square by 2m into pi by a all square. This will be the potential of the particle. One more example. A wave function psi of x equal to a e raised to minus x raised to 4 is the eigenfunction of 1D Hamiltonian with energy 0. The question is to find the potential. So here also the question is to find out the potential, then we have to use the Schrodinger equation. Here we are going to use time independent Schrodinger equation. What is that? That is, we know E psi is equal to h psi. The given wave function is the eigenfunction of 1D Hamiltonian with the energy 0. That is, this energy is equal to 0. That is, 0 is equal to h, where h is the Hamiltonian. That is, we know minus h square by 2m del square psi plus v psi. Where here also the wave function is one dimensional. So this del square operator will reduces to dou square by dou x square. Now we can rearrange this equation, that is v psi is equal to h square by 2m dou square by dou x square of psi. So by calculating this term, we can find out the potential. So first we have to find out dou psi by dou x, and dou psi by dou x is equal to a into e raised to minus x raised to 4 into minus 4x cube. And now we have to find out the second derivative, that is dou square psi by dou x square, that is equal to minus 4a into derivative of x cube, that is 3x square into e raised to minus x raised to 4 plus x cube into derivative of e raised to minus x raised to 4, that is equal to into minus 4x cube. That is dou square psi by dou x square is equal to a into e raised to minus x raised to 4 into minus 4 into 3x square minus 4x raised to 6, where we know this term is nothing but wave function psi. So we get dou square psi by dou x square is equal to, I am multiplying this minus 4 into the bracket, so I get 16x raised to 6 minus 12x square into psi. So in order to find out the potential, we have to substitute this entire term in this equation. That is, we get v psi is equal to h square by 2m into dou square by dou x square, that is 16x raised to 6 minus 12x square into psi. Therefore, we get potential V is equal to h square by 2m into 16x raised to 6 minus 12x square. So this is the answer. Second application of Schrodinger equation, that is time evolution. What is time evolution? We know the state of a particle will change after certain time t. And now we want to find out the state of a particle after some time t. Then how we can find out it? That is the question. So we can find out the time evolution equation for a particle from Schrodinger equation. That is, we know the time dependent Schrodinger equation. That is I h cross dou psi by dou t is equal to h psi, that is equal to E psi, right? That is I h cross dou psi by dou t is equal to energy E into psi. Here I am going to write this equation in the variable separable form. That is, I am taking this psi term here and I am taking this remaining terms to RHS of this equation. That is, dou psi by psi is equal to E by I h cross into dt. Now I can integrate this equation on both sides. That is, integral dou psi by psi is equal to integral E by I h cross dt. So on integrating this equation, what we get? We get log psi limit psi of 0. That is the wave function at a time t equal to 0, and this is wave function at a time t. That will be equal to, here I can take this I term in the numerator, that is minus I E by h cross into integral of dt, that is t, where the limit is 0 to t. Now we can substitute these limits, that we get log of upper limit, that is psi of t, minus log of psi 0 is equal to minus I E by h cross into upper limit is t and the lower limit is 0, right? Now I am going to do a certain mathematical manipulations. That is, I can rewrite this log as log of psi of t divided by psi of 0, that is equal to minus I E t by h cross. Now I want to remove this log. So what do you have to take? You have to take exponential on both sides. So I get psi of t by psi of 0 is equal to e raised to minus I E t by h cross. Therefore, we can write the wave function at time t is equal to wave function at time 0 into e raised to minus I E t by h cross. This is the equation for time evolution. That is, to find out the wave function at time t, what you have to do? We have to multiply it with the exponential term, that is e raised to minus I E t by h cross. We know for a particle in a box, it will have different wave functions. Okay, so these are called psi 1, psi 2, psi 3, etc. psi n, and there will be a corresponding energy E1, E2, E3, etc. En. So this is the ground state and first excited state, second excited state, etc. So the particle can have many states. So in general, we express this as psi n of t is equal to psi of 0 e raised to minus I E n t by h cross. So in order to find out the time evolution of a wave function, we have to substitute its energy in this expression. Okay. So this is the general expression for time evolution. Let us consider an example. Let us consider a 1D box like this one. So for a 1D box, the ground state wave function psi 1 of x will be equal to root 2 by L sin pi x by L. Now I want to find out the value of this wave function after some time t. How we can find out? We have to use this equation, that is psi of x t is equal to root 2 by L sine pi x by L into e raised to minus E1 t by h cross, where E1 is the energy associated with the wave function psi 1 of x. And I tell you, for 1D box, the energy E1 will be equal to pi square h square by 2ml square. So by substituting this value here, you get the exact expression for time evolution of wave function. Now just by substituting the time value, you can find out the wave function at any time. One more example. A wave function x0 is given, that is 1 by root 3 psi 1 of x plus root 2 by 3 psi 2 of x, where E1 is the energy associated with the wave function psi 1 and E2 is the energy associated with the wave function psi 2. Now my question is to find out the time evolution of this wave function, that is we have to find out the equation for this wave function at a time t, that is equal to 1 by root 3 psi 1 of x into, we have to multiply with the exponential term, that is e raised to minus I, what is the energy, that is E1 into t by h cross, plus root 2 by 3 psi 2 of x into e raised to minus I, what is the energy associated with psi 2, that is E2 into t by h cross. So now by just substituting the time value, you can find out the wave function at any time. Okay. Mathematical tools and postulates of quantum mechanics. This one is a brief description only. We will discuss all these postulates in detail later, because to solve some of the expectation value problem, you should be familiar with the postulates and the tools of quantum mechanics. So first I am introducing the idea of Dirac notation. That is, Dirac introduced some of nice representation tools for the quantum mechanics. The first one is, we know a wave function psi, and Dirac represented this wave function as like this one, and he called this as ket. And the complex conjugate of this wave function, that is psi star, he represented like this, and it is called bra. So this is ket vector and this is bra vector, and he represented integral psi star phi d tau as bra psi ket phi. That is psi star, the conjugate term will represent as bra and the other term will represent as ket. And now I am going to tell you some properties of this representation. First one, let us consider a ket psi, and if you are taking its complex conjugate, then we will get corresponding bra vector. Second property, if there is a vector a ket psi, and now we are going to take its complex conjugate, then we get a star bra psi. Third property, ket a psi, where a is a constant, right? Then this will be equal to, we can take this a outside the ket notation into ket psi. And fourth property, bra a psi, this is equal to a star bra psi. That is, when we are taking a constant value outside the bra, we have to take its complex conjugate. Fifth property, bra psi ket psi conjugate is equal to bra psi ket psi. Sixth property, orthogonality. If two wave functions psi and phi are orthogonal, then inner product bra psi phi will be equal to 0. This is similar to vectors. That is, we know the three different vectors, that is I, j, k. These are the unit vectors, right? And if you take product of I dot I, what we get? We get 1. If we took I cap dot j, what we get? We get 0. And if we took I cap dot k cap, what we get? We get 0. Why? Because I and j are at 90 degrees and I and k are also 90 degrees. That is, these unit vectors are orthogonal to each other. That is, there is an angle between them and that is equal to 90 degrees. Seventh property, normalized. We already discussed the idea of normalized. That is, if we took psi psi, we get 1, and if we took psi phi equal to 1. That is, psi and phi are two different wave function, and if they are normalized, then inner product or scalar product of them will be equal to 1. It is similar to I dot I. You know, I dot I is equal to 1. And it is similar to j dot j. J dot j is equal to 1. Eighth property, orthonormal. That is, it is at the same time orthogonal and it is normalized. That is, it will satisfy all these conditions. That is, psi and phi are two orthonormal vectors. Then inner product or scalar product of psi phi will be equal to 0, and the inner product of psi will be equal to 1, and the inner product of phi will be equal to 1. Then we can say these vectors psi and phi are orthonormal vectors. This is a very important point. Here in this question, two vectors are given and it is specified they are orthonormal, and they are asked to find out if they are orthonormal, what is the value of A, B and C. Here I am representing these two vectors as psi 1 and psi 2, where I am calling psi 1 is equal to matrix A0 and psi 2 is equal to matrix BC. And we know if two vectors are orthonormal, then bra psi 1 will be equal to 1, and bra psi 2 will be equal to 1, and bra psi 1 ket psi 2 will be equal to 0. So first two are the condition of normalization and last one is the condition of orthogonality. So here this psi 1 is ket psi 1 and this is ket psi 2. Now we have to find out the bra psi 1 and bra psi 2. So we can substitute those values in these equations and we can find out the values of A, B and C. So what will be the bra psi 1? Generally we know bra psi 1 is complex conjugate of the function. Here the given function is a matrix. So when taking the complex conjugate of this matrix, we will get a row matrix, that is A0, and bra psi 2 will be BC. So generally ket vectors are represented by column matrices and bra vectors are represented by row matrices. Now we can substitute these terms in these equations. Right. So first consider the first equation. Then what we get? The bra psi 1. Bra psi 1 is matrix A0 and ket psi 1 is matrix A0. And these vectors are normalized. So we get this is equal to 1. So what is this equal to? That is, by multiplying this matrix we get A square, and A square is equal to 1. So we get A equal to plus or minus 1. Now we can substitute for the second equation, that is bra psi 2 is equal to BC into BC, and that will be equal to 1. That is B square plus C square is equal to 1. Now the third condition, that is bra psi 1, that is matrix A0 into psi 2, that is B, that is equal to 0. That is AB is equal to 0. Here from the first equation we got A equal to plus or minus 1. So for this equation to be equal to 0, B should be equal to 0. Now we can substitute this value of B here. So B is equal to 0. So we get C square equal to 1, that is C equal to plus or minus 1. So you check the options, you get option C as the right answer. In this question, a potential is given and the particle is confined in the potential. And what is the plot of this potential? That is half m omega square x square. It will look like this one. If this is x-axis and this is y-axis, then it will look like this one. That is y is equal to half m omega square x square plot. But here they added one more condition, that is v of x is this value for x greater than 0 and infinity for x less than 0. That is, for this region it is infinity. The potential is infinity. Here v is equal to infinity. That means the particle is confined in this region. It can go to the negative x-axis. The particle will oscillate only in this region. Okay. So this is not representing a linear harmonic oscillator. So there is no symmetry. So this is called asymmetric linear harmonic oscillator. And for an asymmetric linear harmonic oscillator, the possible energy eigenvalues, that is En, is defined as 2n plus 3 by 2 into h cross omega, where this n can have values 0, 1, 2, etc. If you are substituting n equal to 0, then that will give the ground state energy of a particle confined in this potential. Okay. And in the question they specified the wave function of the particle, that is psi of x is equal to minus 1 by root 5 psi 0 plus 2 by root 5 psi 1. And here the question is to find out the expectation value of energy, that is equal to psi of x Hamiltonian psi of x divided by bra psi of x ket psi of x. This is the expression for finding the expectation value of energy. That is, energy E is equal to bra psi of x, that is complex conjugate of this function. Here all are real values, so complex conjugate will be same. That is, we get minus 1 by root 5 psi 0 plus 2 by root 5 psi 1 into Hamiltonian operator into minus 1 by root 5 psi 0 plus 2 by root 5 psi 1. So when this Hamiltonian operates on this wave function, it will give the energy associated with this wave function. Here, what is the energy associated with this wave function? So to find out the energy of psi 0, we have to substitute n equal to 0. So what we get? We get this is equal to 3 by 2 h cross omega. So when Hamiltonian acting on this wave function, it will give 3 by 2 h cross omega. And when this Hamiltonian operates on psi 1, that will give its energy. That is, what is its energy? Here, E1, that is equal to, we have to substitute 1 for this n, that is 2 plus 3 by 2, that is 7 by 2 h cross omega. Here, if you solve this one, then you will get this is equal to 1. Therefore, we are not bothering about the denominator when finding out E. If it is not normalized, that is, if it is not equal to 1, then you have to divide this entire term by this value. Okay. Here it is 1, so we get the same value, right? Okay. Now we have to find out the energy expectation value, that is equal to minus 1 by 5, this is bra psi 0 plus 2 by root 5 bra psi 1. When this Hamiltonian operator operates on this wave function, we will get this energy values. Okay. Okay, so we can substitute those values here, that is minus 1 by root 5 into 3 by 2 h cross omega, get psi 0 plus 2 by root 5 into 7 by 2 h cross omega, get psi 1. Here again, the scalar product of these two will be equal to 1 and these two will be equal to 1. And all other combinations will be equal to 0. Okay. That is, we get E is equal to 1 by 5 into 3 by 2 h cross omega plus 4 by 5 into 7 by 2 h cross omega. That is, we get E equal to 3 by 10 h cross omega plus 4 into 7, that is 28 by 10 h cross omega. That is, we get E is equal to 31 h cross omega by 10. So this is the answer. Here the state of a system is given. That is, psi is equal to get psi 1 plus 2 psi 2 plus 3 psi 3. So the particle can have in any of these states, that is psi 1 or psi 2 or psi 3. Okay. And the state of system is the combination of these three wave functions, psi 1, psi 2 and psi 3. Okay. That is like a particle in a 1D box can be in ground state, or maybe it is in the first excited state, or maybe it is in second excited state. So there is a probability for the particle to be found in ground state or in first excited state or in second excited state. So we can represent the state of the system as a combination of these different states. That is what given here. That is, the state psi is a combination of psi 1, psi 2 and psi 3. And this phi 1, phi 2, phi 3 forms an orthonormal set. And here the question is to find out the probability of finding the system in the state psi 2. That means the particle can be in any of these states, and the question is to find out the probability of finding it in phi 2 state. Okay, so how to solve this problem? To solve this kind of problem, first we have to normalize the function. Second step, find the modulus square of coefficient of state. That is, here it is get phi 2. Okay, so this is the procedure. So first you have to normalize the given wave function, that is psi is equal to get phi 1 plus 2 get phi 2 plus 3 get phi 3. So how we can normalize? That is, normalization is bra psi get psi is equal to mod psi square, that is equal to integral minus infinity to infinity psi star psi dx, and this should be equal to 1. So if mod psi square is not equal to 1, then we have to make it equal to 1. That process is called the normalization. So here we have to find out this value bra psi get psi, that is equal to bra phi 1 plus 2 bra phi 2 plus 3 bra psi 3 into get psi 1 plus 2 ket phi 2 plus 3 ket phi 3. Okay, and in the question it is specified phi 1, phi 2, phi 3 are orthonormal set. So if you are taking an inner product of psi 1, we will get a value 1, and if you are taking this combination, we will get a value 1, and if you are taking this combination, we will get a value 1. For all other combination, this is equal to 0. So we get psi is equal to 1 plus 4 plus 9, that is 14. That means this wave function is not normalized. If it is a normalized, then we get this value equal to 1. But here it is 14. So how we can make this value equal to 1? That is, there is a method, that is, we have to divide these terms by 1 by root 14 psi into 1 by root 14 into psi. Okay, so we will get a value is equal to 1. That is, this is the normalized wave function. That is the normalized wave function psi. I am calling it as some other terms, that is psi bar. Okay, psi bar is the normalized wave function, that is equal to 1 by root 14 into what is psi? You know, psi is equal to ket psi 1 plus 2 ket phi 2 plus 3 ket phi 3. That is, this normalized wave function is equal to 1 by root 14 into psi 1 plus 2 by root 14 into psi 2 plus 3 by root 14 into psi 3. Okay. Now we got the normalized wave function. Now we want to find out the probability of finding the particle in this phi 2 state. I told you the probability for finding particle at psi 2 state will be equal to modulus of coefficient of this term, that is 2 by root 14 square, that is equal to 4 by 14, that is 2 by 7, and this value approximately equal to 0.28. So we got the answer. And similarly, for finding the particle in state psi 1 is equal to modulus of coefficient of psi 1, that is 1 by root 14 square. So you get this is equal to 1 by 14. And the probability of finding the particle in phi 3 will be equal to the coefficient of psi 3, that is 3 by root 14 square, that is equal to 9 by 14. Now if you add these probabilities, then you will get a value is equal to 1. That is the total probability of finding the particle is 1. Okay, and that probability is distributed among different states. Here in this question, two possible states are given, that is psi 1, that is equal to 1 0, and another state get psi 2 is equal to 0 1. So the particle can be found in any of the state or any combination of these states. And here a density matrix is defined, that is rho is equal to C1 get psi 1 bra psi 1 plus C2 get psi 2 bra psi 2. Here they specified the C1 value is 0.4 and the C2 value is 0.6. And the question is to find out rho 2 2. That is the matrix element rho 2 2. That is, this density is a matrix, that is rho is equal to rho 1 1, rho 1 2, rho 2 1 and rho 2 2. So here we have to find out this value, that is the question, right? Here in this rho 1 1, the 1 means the state psi 1. Okay, and the second state is again psi 1, that is get psi 1. Here the first term is psi 1, that is this psi 1, and the second term is psi 2, that is here it is psi 2. So when we are taking this combination over this row, we get rho 1 1, that is rho 1 1 is equal to bra psi 1 rho psi 1, and rho 1 2 is equal to this one bra psi 1 rho psi 2 get psi 2. Similarly rho 2 1, that is this term, here this will be psi 2 will be equal to bra psi 2 rho get psi 1, and rho 2 2 will be equal to bra psi 2 rho get psi 2. Okay, so this is what they are asked to find out. Here in this question they given the rho value. So what you have to do? You have to just substitute that value here and find out, that is rho 2 2 is equal to bra psi 2 into this same rho, that is C1 get psi 1 bra psi 1 plus C2 get psi 2 bra psi 2 into get psi 2, right? Here these states are normalized, so we get psi 1 equal to psi 2 equal to 1, and bra psi 1 get psi 2 equal to, and bra psi 2 get psi 1 equal to 0. Now we can substitute this condition here and multiply. So what we get? So we get rho 2 2 equal to, see here this term only exists, okay, and the combination of this term is equal to 1, so we get C2 value here, right? Now check, is any other combination will exist? No, because of this orthogonal condition. Therefore we get rho 2 2 is equal to C2. In the question they are specified C2 value is equal to 0.6. So this is the answer. In this question, a wave function psi of 0 is given, and that is equal to 1 by root 2 ket u1 plus ket u2. Where it is specified this ket u1 and u2 are normalized eigenstates with the energy E1 and E2. And it is specified E2 is greater than E1. And the question is, after some time t, we get a wave function psi of t, and it will become orthogonal to psi of 0. That is, when we are taking scalar product of psi of 0 with the psi of t, we get this is equal to 0. Here the question is to find out the shortest time after which psi of t become orthogonal to psi of 0. So how we can solve this? We have to find out the time evolution of psi of 0. So we get psi of t, then use this condition, and from this condition you can find out the time. So this is the procedure. After solving this equation, you get the answer option B. Okay, I will tell you how we can solve it. So here first we have to find out the psi of t. I already told you how we can find out the time evolution of a wave function. That is, if some wave function is given at 0 time, then we can find out psi of t, the wave function at a time t, as e raised to minus I e t by h cross into ket psi of 0. Okay, so we have to use this equation to find out this psi of t. That is, psi of t is equal to 1 by root 2 into ket u1 e raised to minus I. Here what is the energy associated with this state u1? That is E1. That is E1 t by h cross plus u2 into e raised to minus I e2 t by h cross. Now we have to use this orthogonality condition, that is scalar product of psi of 0 with the psi of t. So what we get? So to find out the bra psi of 0, we have to take complex conjugate of this time. So here this is a real wave function, so complex conjugate will be same as this one. That is, we get 1 by root 2 bra u1 plus bra u2 into second time, that is psi of t, that is equal to 1 by root 2 ket u1 e raised to minus I e1 t by h cross plus ket u2 e raised to minus I e2 t by h cross. So that is, we get 1 by 2 into product of these two terms, that is, we get e raised to minus I e1 t by h cross. Here these are normalized, that is u1 and u2 are normalized. Therefore, scalar product of u1 will be equal to 1, right? So we get this term only. Plus, now we have to take the second term. Second term is this one and this one. Here we know u1 and u2, scalar product of u1 and u2 will be equal to 0 because it is normalized wave functions. So this term will be equal to 0. Now we have to consider these two terms, that is again u2, u1. So that will also become 0. And the last term, scalar product of u2, u2. So that will be equal to 1. So we get e raised to minus I e2 t by h cross. And the question is to find out this t value when they are orthogonal. That is, this is equal to 0. That is, we get e raised to minus I e1 t by h cross plus e raised to minus I e2 t by h cross is equal to 0. Now I am doing some mathematical manipulations, that is, I am taking these terms to RHS of this equation. So I can rewrite this as e raised to minus I e1 t by h cross is equal to minus e raised to minus I e2 t by h cross. Again, I am doing some mathematical manipulation, that is e raised to minus I e1 t by h cross is equal to minus 1 by e raised to I e2 t by h cross. So now I can multiply this term to here, left hand side, that is I get e raised to minus I e1 t by h cross into e raised to I e2 t by h cross is equal to minus 1. And this is equal to e raised to I e2 minus e1 t by h cross. That is equal to minus 1. So here the question is to find out the time value. And here the left hand side is exponential function and right hand side is just minus 1. If we can write this minus 1 as an exponential function, then we can easily equate these two. We know e raised to I theta. What is e raised to I theta? This is equal to cos theta plus I sin theta. Then what is e raised to I pi? That will be equal to cos pi plus I sin pi. What is sin pi value? That is equal to 0. Then what is e raised to I pi? That is equal to cos pi, that is minus 1. So we can rewrite this minus 1 as e raised to I pi. Not only e raised to I pi, e raised to 3 I pi is also equal to minus 1. E raised to 5 I pi is also equal to minus 1. But here in the question, they have specified one thing. We have to find out the minimum time when this psi of 0 become orthogonal to psi of t. So the minimum value is this one only. Okay. That is e raised to I e2 minus e1 t by h cross is equal to e raised to I pi. So this entire term is equal to pi. So e2 minus e1 t by h cross is equal to pi. That is, we can easily find out the time t, that is equal to pi h cut by e2 minus e1. So this is the answer. Here in this question, two states are given, that is ket 1 and ket 2, and their energies are given, that is E1 and E2. And the state of the system at time t equal to 0 is given, that is equal to sin theta ket 1 plus cos theta ket 2. Here the question is to find out scalar product of psi of t with the psi of t. So what do you have to find out? You have to find out the time evolution of this state. That is psi of t is equal to sin theta e raised to minus I. Energy of the first state, that is ket 1, is E1 t by h cross ket 1 plus cos theta e raised to minus IE is E2 here, E2 t by h cross ket 2, because the energy associated with the ket 2 is E2. Okay, so now we got the psi of t. Now what do you have to do? You have to find out the scalar product of psi of t. That is psi of t is equal to bra psi of t, that is the conjugate of this term, that is sin theta. Conjugate of sin theta is sin theta itself, and the conjugate of this term is e raised to this minus become plus, that is I E1 t by h cross ket 1 become bra 1 plus this term, that is cos theta. Conjugate of cos theta is cos theta itself into conjugate of this term become e raised to I E2 t by h cut bra 2 into ket psi t, that is sin theta e raised to minus I e1 t by h cross ket 1 plus cos theta e raised to minus I e2 t by h ket 2. Now we have to multiply these terms. So when multiplying these two terms, we get a value because this bra1 with the ket 1 will give a value 1, and for this term also the bra2 ket 2 will give a value 1. All other term, that is bra1 ket 2 and bra2 ket 1 terms will be equal to 0. So we get psi of t is equal to sin square theta, and the product of these two terms is equal to 1 plus, and product of these two terms is cos square theta into product of e raised to I e2 t by h cross and e raised to minus I e2 t by h cross is equal to 1. That is equal to, we know sin square theta plus cos square theta is equal to 1. So this is the answer. This is a problem related to 1D linear harmonic oscillator. Here what is the question? The state vector of a SHO is given, that is psi of 0, that is at time t is given, is equal to 1 by root 2 into ket 0 plus ket 2. Here they specified ket 0 and ket 2 are normalized, and they are ground state and second excited states of linear harmonic oscillator, and they are asked to find out the time after which this vector psi of t is orthogonal to psi of 0. So we know when they are orthogonal, this is equal to 0, and the question is to find out the time at which they become orthogonal. Okay, so we have to find out the time value. Here to solve this problem, we have to find out psi of t, that is time evolution of ket psi of 0. That is ket psi of t is equal to 1 by root 2 into e raised to minus I E0, that is I am calling E0 as ground state energy, E0 t by h cross ket 0 plus e raised to minus I E2 t by h cross ket 2. To solve this problem, we should know what is the ground state and the second excited state energies of a linear harmonic oscillator. For a 1D linear harmonic oscillator, the energy of any state, that is En, is equal to n plus half h cross omega, where n is equal to 0, 1, 2, etc. If we substitute n equal to 0 in this equation, we get energy of ground state, and if we substitute 1 in this equation, we get energy of first excited state, and if we substitute 2, we get second excited state. So what is the ground state energy? That is n equal to 0, that is E0 equal to half h cross omega. And what is E2? That is equal to 2 plus half, that is 5 by 2 h cross omega. Here this equation is very important. I will derive this equation when we are discussing about 1D simple harmonic oscillator. Right now you just remember this equation. This is very important equation. Later we will derive this equation. Okay. So here we got this E0 and this E2. Right. Now what we have to do? We have to substitute these values here. So we get ket psi of t is equal to 1 by root 2 into e raised to minus I into E0, that is half h cross omega, that is h cross omega t by 2 h cross ket 0 plus second time, that is e raised to minus I E2 is pi by 2 h cross omega by h cross. So we can cancel this h cross and h cross and this h cross and h cross, right? That is, we will get psi of t is equal to 1 by root 2 into e raised to minus I omega t by 2 get 0 plus e raised to minus I 5 omega t by h cross. Now we have to use the orthogonality condition, that is bra psi 0 get psi of t, that is equal to, this will be equal to 0. So first we have to find out these terms, that is bra psi of 0 is given, that is equal to 1 by root 2 into bra 0 plus bra 2 into get psi of t, that is 1 by root 2 into e raised to minus I omega t by 2 get 0 plus e raised to minus I 5 omega t by h cross. When we are doing this multiplication, these two terms will exist and this two term will exist. All other term will be equal to 0 because we know here it is inner product of 0. So that will be equal to 1, and here it is inner product of 2, that will be also equal to 1. And all other combination will be 0, right? That is, we get psi of 0 get psi of t is equal to 1 by root 2 into 1 by root 2, that is 1 by 2 into e raised to minus I omega t by 2 plus e raised to minus I 5 omega t by, sorry, here I made a mistake. This is not h cross, this is 2 and this is also 2. Okay. And this value is equal to 0. That is from orthogonality condition. So I can rewrite this equation as e raised to minus I omega t by 2 is equal to minus e raised to minus I omega t by 2. That is, I am rewriting this equation. E raised to minus I omega t by 2 is equal to minus 1 by e raised to I 5 omega t by 2. That is equal to, here I am multiplying this term to LHS. So we get e raised to minus I omega t by 2 into e raised to I 5 omega t by 2, that is equal to minus 1. That is e raised to I into 5 minus 1 omega t by 2 is equal to minus 1. That is e raised to I 2 omega t is equal to minus 1. And we know e raised to I pi is equal to minus 1. That is e raised to I into 2 omega t is equal to e raised to I pi. So we can equate these two terms, that is 2 omega t is equal to pi. Therefore we get t is equal to pi by 2 omega. So this is the answer.